Jupiter, the gas giant of giants, a swirling beast of monstrous storms, deadly radiation, and mind-bending beauty. It's so massive its gravity pulls on the Sun. Yeah, you heard that right. And despite being over 480 million miles away, Jupiter is fast becoming the most studied, respected, and maybe even feared object in our solar system. With 7 flybys, 2 orbiters, 1 still orbiting right now, and more missions already in the pipeline, there's a reason everyone's watching. So what gives Jupiter its iconic red color? What's underneath those hypnotic cloud bands? And what's the real story behind that massive storm, the Great Red Spot? Hey there, I'm Alex McColgan, and welcome to Astrum. Today, we're taking a deep dive into the mighty Jupiter. Let's go. Jupiter's the 5th planet from the Sun, hanging out right beyond the asteroid belt, sandwiched between Mars and Saturn. It's huge, I mean really huge. Over 318 times the mass of Earth and more than twice as heavy as every other planet combined. It's basically the heavyweight champ of the solar system. To put that into perspective, Jupiter is so massive, the center of gravity between it and the Sun, the barycenter, isn't even inside the Sun, it's in space. That's wild. Because of that mass, Jupiter's gravity is no joke. 2.5 times stronger than Earth's. It doesn't just tug on nearby moons, it shapes the solar system. In fact, without Jupiter, Earth might not even be here. It's the ultimate cosmic bouncer, pulling in rogue comets, shattering asteroids, and keeping dangerous objects away from the inner planets. It's earned the nickname the solar system's vacuum cleaner. And its gravity is so disruptive, it's even throwing Mercury's orbit off kilter. Some predictions say that billions of years from now, Mercury might get flung into the Sun or shot out of the solar system altogether, thanks to Jupiter. Despite being 5 times farther from the Sun than Earth, Jupiter is often the 3rd brightest object in our night sky, after the Moon and Venus. Sometimes it's so bright it can cast shadows. You can even see it with a basic camera or backyard telescope, and trust me, the view is worth it. That iconic striped look? It comes from Jupiter's upper cloud deck, about 50 kilometers thick, made mostly of ammonia crystals, but the colors come from compounds called chromophores that rise from deep inside and get cooked by sunlight. These colored bands are wild. They shift in tone and width, but always stay in their lanes, literally. The turbulence where they meet fuels massive storms, including the Great Red Spot. The Great Red Spot is a storm so massive you could drop all of Earth inside it and still have room to spare. It's been raging for centuries, possibly over 350 years, and although it's shrinking, it's still a dominant force on the planet's surface. We still don't know exactly what causes its red color, but it's likely similar to Jupiter's other bands. UV light breaking down chemicals high in the atmosphere. Fun fact, there's a second storm nicknamed Wilkie's Red Spot Jr., formed by 3 smaller storms merging. It's smaller, but still fierce, and has lasted over 2 decades so far. So what's Jupiter made of? Mostly hydrogen and helium. The same stuff that makes stars. In fact, if Jupiter had been 75 times more massive, it could have become a star. Inside, hydrogen turns liquid, then a metallic under insane pressure. Pressure we can't even recreate on Earth. Somewhere deep inside might be a core of rock and ice, but honestly, we're still not sure. Jupiter also rotates incredibly fast, once every 10 hours, making it the fastest spinning planet in our solar system. And because it's not solid, different parts rotate at slightly different speeds. Yep, Jupiter has rings. 4 to be exact. They're not as showy as Saturn's, but they're there. The brightest one is thin, wide, and known for a unique kink called the Métis notch. But maybe the most underappreciated thing about Jupiter? Its magnetosphere. It's 14 times stronger than Earth's, and second only to the Sun's. That makes it a radiation mon. It's 14 times stronger than Earth's, and second only to the Sun's. That makes it a radiation monster. with deadly belts strong enough to fry spacecraft. Its moon Io passes through these radiation bands, taking in more than 3,600 rems of radiation per day. That's enough to kill a human in hours. So, is this real or just a mind game? Here's where it gets really exciting. Gravastars solve some of the most troubling paradoxes of black holes. No singularity, no information loss, no tearing of space-time. They could be the answer to physics' biggest headaches, but they also introduce new mysteries. What is this exotic shell made of? How can nothingness hold so much energy? Still, just like black holes once were, gravastars work on paper, and we might be closer than ever to finding out if they're real. Echoes from the cosmos. Listening for gravastars. There's one key difference between black holes and gravastars. Black holes have an event horizon, a point of no return. Gravastars have a physical shell. This means they behave differently when they collide. Black hole collisions create short, sharp gravitational wave signals like a quick bass drum. But two gravastars colliding, that should echo like a gong, subtle ripples stretching out in space-time. Physicists are already listening to these gravitational echoes, but the signal is faint, like trying to hear whispers through concrete. Our instruments aren't quite there yet. Point: why this matters. Are gravastars real? Maybe. Maybe not, but that's the beauty of science. Black holes were once just weird equations. Now we have images of them. Gravastars are the next idea to chase, the next mystery to solve. They might be wrong, or they might change everything, because that's what science is about, not answers, but better questions. A universe that's stranger and more beautiful than we ever imagined.